So now let's talk about data structures. We all love data structures, right? Data structures are about optimization, fundamentally, right? What happens is your program has a query that it wants to make, like what are all the objects in this area of the map, or like what are all the strings starting with Q or whatever, right? And data structures are about storing your data in a ways to answer that query efficiently, right? Unless you start talking about trivial data structures like a record or something, which is really just about if I want the name, like where is that stored in memory? But that's kind of trivial, So when I say data structures, I'm talking about we're organizing things with pointers in certain ways to let us navigate stuff or whatever, right? So like a binary tree or a hash table or pick your favorite skip list, anything, right? So data structures are about optimization, and I've just said that optimization is usually bad. Therefore, using the right data structure for the situation that you are programming is usually bad because it constitutes premature optimization, right? I actually never realized this in terms this clear until I sat down to give this talk, but I absolutely believe this. Let me give you an anecdote about this that actually dates back to about the time I was in college. This game is Doom. It doesn't look like much now, but this was awesome back when it came out because nobody really knew that computers could do like 3D this fast in like arbitrary spaces. And, so shortly after this game came out, there was a mailing list. They released the source code, which was pretty progressive. And there was a mailing list for like people who wanted to make modding tools for the game, And I was kind of interested in that, so I was on that list. And there was a question that came up about the asset loading code in Doom, right? So the way Doom works is the assets in the game, right, which is bitmaps and sound effects and all strings and all that kind of stuff, is stored all in one contiguous package. And, at the beginning of that package, there's just a header that tells you the name of an asset and then where in the file it's located, and it's packed very tightly in that very simple way. Name, number of bytes in the file, name, number of bytes in a file, just like that. And a question came up, on this mailing list, isn't that slow? And I went and took a look at the code, and I got nerd rage, like full on, man. I was like, this is stupid, They're taking an asset name, they're calling a function to look it up in the data, and they're doing a linear search, starting at the beginning and going through every name till they get to the end, right? I totally learned in school how slow that is, right? You should build a hash table so you can, like, look it up in constant time, or you should at least, if that's a little too slow or whatever, just build a little more stuff into the file so you can binary search it, right? And then at least get log in time, right? And I said on the mailing list, like, yeah, this is totally lazy programming. They should do that and that, right? And John Romero's on the mailing list, and he emails back like, oh, you don't know what you're talking about, blah, blah, blah. We worked really hard on this game and stuff. And I was totally convinced I was right. I had my nerd indignation. But no, I see very clearly at this time that I am totally wrong, right? Their implementation was the totally dumbest thing. Start at the beginning of the file, don't even unpack anything, scan the file till you find the thing. And that's absolutely right. And the reason why is because if I'd sat down to program that, well, first of all, if you profile the loading time of Doom, which I know about because I later ended up porting it to a couple things, it turns out that the amount of time that's actually spent in this string lookup is negligible compared to the other time spent loading the data, right? So that's the first thing. Even though like the spider sense starts tingling when you look at this code, like, oh, it's important to optimize this. In reality, right, and reality is the important benchmark to think about, in reality it did not matter what the implementation is, except it did not matter in terms of runtime, but it mattered in terms of all sorts of other things, right? So, and what I would have done would have been much worse, like putting a hash table in there, would have been much worse along all other axes, right? It would have taken more time to implement, it would have used more memory, it would have fragmented the heap, it would have had less predictable performance characteristics depending on what the level is, it would have made the executable bigger, it would have been harder to understand and been more bug prone, it would have made the source code longer, take longer to compile, longer to link. All for no perceivable benefit, right? It's actually worse in every single way that I can think of now than what they did. But I was convinced at the time that I was right, Now take that is just one tiny piece of Doom. This is a very complicated game, right? So take the difference between what I would have done and what they did and multiply it not just by that tiny piece, but by the hundreds or thousands of pieces comprising this whole game. And you can imagine how much better of a job they did making this game than I would have if I had sat down to do it, right? They were simply better programmers than I was at that time, right? But I thought I was really smart. And there's an issue here that goes beyond being smart, right? There's some kind of issue of operational wisdom. I'll go into part of it later, but at least the most obvious part of it here that I should have had, but that people don't generally have is like, here's some guys who made this really cool game that I don't know how to make, right? And it's like made by a couple programmers. If I think something's wrong with what they did, but what they did is kind of beyond my capability, maybe I just don't understand why they did what they did, right? Why am I saying they suck when all concrete evidence in the universe says that they don't suck, right? This is a pattern I see. Again, talking about the internet, this happens on the internet all the time, right? So just keep that in mind. So what I do now when I write a program is I use an array of records for almost everything. I don't know if you guys call it records still. When I say records, I think of Pascal, which is a language I never, so a record is just like, hey, here's the fields, and they're just like, you don't really care how they're stored, but they're probably stored linearly in memory. And then I just have an array of those, and I just put a record in the array, done. Almost every data structure in the games that I make now is like that. And the reason is because it doesn't matter, and if you think about it at all, right, then you're wasting time. So if I'm doing something with an array of records, I can type it in without thinking. I know it's going to work unless I'm way too tired, right, and make a terrible bug. I know it's going to be perfectly fast enough, and I also know that it's modular enough because it's not some crazy implementation, right? I know it's modular enough that if I need to rewrite it later for performance reasons, I can, because it's just like 4 lines of code, right? But I won't do that rewrite until the need actually arises.